Okay, now in this video we're going to do example 2.5, and this is asking us to find the average rate of change for two different runners running a race. So we have a red runner, which I will call this function r of x, and then we have a blue runner, b of x, and it says here that the two runners start a race side by side. Their distance from the starting lines are recorded in the graphs below. Find the average rate of change, speed or velocity, of each runner over each of the following intervals. And so what we want to calculate is for the red runner, we want to calculate delta r over delta x on the interval from 0 to 2. And so that will be, let's see here, well, we start at 0, 0, and when x is 2, we're at 3. So we have 3 minus 0 for the change in r. And then, or change in distance. I mean, this is, I guess it's really change in distance, but I'm doing red, so let's just let r be the red distance and b be the blue distance, I guess. Okay, and then the change in x is 2 minus 0. Okay, so what we've done is we've calculated the slope of that line there, because this is the change in r, and then this would be the change in x. And so we're taking delta r over delta x, and so we should get 3 halves. For the blue runner, well, that goes 0, 0, and 2, 2, so we'll be calculating the slope of this line, which is the change in b over the change in x. And so delta b over delta x on the interval from 0 to 2 is going to be 2 minus 0 over 2 minus 0, and so that's an average rate of change of 1. Okay, so the slope of the blue line here is 1. The slope of the red line is 3 halves. Okay, now I'm going to delete that to clean this up just a little bit. Next, we want to calculate the average rate of change from 2 to 4. Okay, so let me see here. We're going to look at 2, 3, and then 4, 4. So we're going from x equals 2 to 4 in this interval. So now we're doing part B. And what we're going to get is 4 minus 3 over 4 minus 2. So the change in y was 4 minus 3. The change in x was 4 minus 2. So we get 1 half. So that means the slope of this red line here is 1 half. And then delta b over delta x from 2 to 4 is going to be, well, we're starting at 2, 2, we're ending at 4, 4, so this is 4 minus 2 over 4 minus 2, and so there the slope is 1. We calculated the slope of that blue line there is 1. Okay, and so the last thing we need to do is to do part C, and that's to find the average rate of change over the whole interval from 0 to 4. So delta r over delta x on the interval from 0 to 4, the average rate of change over that interval is going to be 4 minus 0 over 4 minus 0, which is 1. Similarly, you can calculate delta b over delta x. That's also going to be 4 minus 0 over 4 minus 0, and that's 1. And so the takeaway here is that even though the red runner starts off running faster, the average rate of change over the entire interval is still just 1. It's still just 1. So for both of these, the slope is the slope of that purple line. Right? So they get to the same place after an interval of 4, and so their average rate of change is the same, even though one started faster than the other. Okay, that's it. Thanks for your time.